Good morning, everyone. I'm glad you could all come out this morning. So, yes, why we should all write video games. This keynote is kind of in 6 parts, but they all relate to each other. We'll see how we go. Part 1 is about kids with computers. My daughter is 8. She has 5 computers at home that she's allowed to use. There's a PlayStation 3, a Wii, a Windows PC, an iPad. She also has an Apple iBook, but it doesn't cope very well with modern life, so it doesn't get much use. Me, on the other hand, we have to jump back 30 years here. In the early 80s, I was interested in the usual stuff that kids were back then, wearing rockin' pointy hats, that's me on the left, riding a bike, playing with my Lego, reading fantasy and science fiction novels, watching Daryl and war games. We'd just come off the back of Star Wars. It was so cool. Kudos to Lucas there. My first computer that we had in the house was a Commodore 64 with a with a MOS 6510 CPU running at 0.9 megahertz. It was so cool. The 6510 was a variant of the 6502, which was used in stacks of computers at the time. The Apple I and II, the Atari 2600 game system, the Nintendo Entertainment System, or NES, the VIC-20, and the BBC Micro. It also apparently ran the T800 series Terminator, as you can see by the code in the cyborg display there. The 64 had a whopping 64 kilobytes of addressable space, 38,911 bytes of RAM. It also had a serial port, parallel port, a cartridge port for video games, and most importantly, 2 gaming ports that were compatible with the Atari 2600 game system, and an RF output to plug it into your TV. I blew up one of the CIA chips, the 6526 CIA chips. That stands for Complex Interface Adapter. I blew one of those up when I was working on some homebrew circuitry, and I left the circuit plugged into the powered-on computer while I was doing some soldering, and poof. It was easily fixed though, because the CIA chips are mounted in sockets on the motherboard, so the repair guy just had to swap out the chip. My first programming book was the Commodore 64 Programmer's Reference Guide. It came with the computer, and it taught me BASIC. It taught me Hello World. Sometimes, infinitely scrolling up the screen. 10, print Hello World. 20, go to 10. It was great. The book was packed with lots of little code snippets that I could just copy over and run, just by flipping the power switch on the 64, waiting a couple of seconds and banging away at the keyboard. Some of the examples were a touch longer and took a while longer to type out. This is an example from the sprites chapter, and it generates an animated sprite. The dancing mouse is actually quite infamous in my family, as it took my mother some considerable time to type in, and she was a little bit disappointed with the outcome. I thought it was pretty cool. When you're that young, and in those days, it didn't take much to be very impressive. I then convinced my parents to buy me the book, The Challenging Games for Commodore 64, which had, I think, about a dozen games in it that you could just copy in from the book and try out and experiment with. This is a maze game. It's horribly complex. But it was great fun. Eventually I migrated to the Amiga 500, which had a Motorola 68,000 CPU and more RAM, and powerful co-processors called Agnes, Daphne, and Portia. They were great. Agnes actually had 2 components inside of it called the Blitter and Copper. Copper actually stands for coprocessor, and it could run very simple programs all on its own. I experimented with the various drawing capabilities that we had there and special effects and even some 3D rendering. The computer didn't actually have any 3D capability, you had to code it up all yourself. I joined a demo group and we made some art. I wrote my own floppy disk bootloader that we could have on our disks so that when the disk booted up it showed our logo instead of the usual Amiga logo. That was a really good challenge because you didn't have much room to fit on the disk boot sector. I implemented proper multiprocessing by having one of the coprocessors, the copper, program the other coprocessor, the blitter, using instructions fed to it from the CPU. And it ended up drawing a 3D wireframe cube. I mean, it wasn't fantastic, but it was pretty exciting stuff. And figuring out that you could actually program one of the coprocessors from the other coprocessor, that was pretty eye-opening. Both the Commodore 64 and the Amiga came with manuals for programming them in BASIC. Could you imagine the fun we could have if the PlayStation, when you plugged it into the television, booted into a programming environment like I had with the Commodore 64 or Amiga? So back to my daughter. The iBook has Python installed, which is neat, and we've played with the Turtle module a few times. But as I mentioned, the iBook isn't coping with modern life. It has a PowerPC CPU, and pretty much no one builds software for that anymore. And it all runs terribly slowly if it does. I'm going to be investigating options for the Windows PC in the near future, but it's not convenient for her to use. And it doesn't come with a useful programming environment built in. And then, of course, that was that recent news that Microsoft announced that they were going to be discontinuing their free C compiler for Windows 8. Which apparently they've just reversed overnight, which is, a good thing, but I mean, it is engaging with enthusiasts. Remember though, my first computer booted into BASIC. The iPad is my wife's, and I mean, those things are single-user devices. So my daughter's, she's allowed to play games on it sometimes. iPads are being introduced into early education. Now, this is actually a topic that deserves its own keynote, and I'm not going to do that today, but I am going to touch on it a bit because it really bugs me. What concerns me is that these kids are being given these hermetically sealed iPads as their computing devices. They consume and maybe they produce some media on them. It's usually just a bunch of busy work. There's no doubt that there's a range of great content creation tools on them. They can draw, they can make music, and maybe even edit movies. There's even a reasonably neat coding platform on there called Codea. It used to be called Codify. It's built using Lua as the programming language. It exists on the iPads despite burdensome controls that Apple imposes. The big problem is that creators can't share their code. Apple required that functionality be removed for it to be sold on the App Store. The app reviewer even went as far as saying that typing in code line by line copied from the web constituted downloadable code. But it's certainly better than nothing. And apart from being able to share programs, it closely resembles what I started out with. And although Lua has problems as a language, it's actually far improved over the BASIC that I started with. But it's a walled garden, or, as one commentator liked to say, a lovely expensive hotel with just a lot of rules about things you're not allowed to do, like move around the furniture or bring in your own food. But their ability to control the device, really control it, is really limited. One of the little experiments I did with the Commodore 64 was to plug in an array of LEDs into the back and make them light up in different patterns. The total parts cost was maybe a couple of dollars, and I paid for it out of my own pocket money. But my ability to cross the divide between the computer and the rest of the world was really eye-opening. And it was probably pretty instrumental in me getting into robotics. And really, just typing on an iPad is a pain. But mostly it's about the walled garden. I think it's disempowering. We should be enabling these kids to make full use of modern technology by demystifying it. Give them some appreciation of how it works, but also the understanding that they can take control of their computers. And perhaps along the way, give their logical and organisational skills a few challenges. I can't help but wonder where our next generation of software developers are going to come from if this is the computing worldview they get at an early age. And on demystifying of technology, very early programmers were required to test virtually every program step, and they were cautioned not to expect that, given that the resulting program would just somehow do the right thing when given imperfect input. Charles Babbage, the creator of the first computing device, noted this on 2 occasions. "Pray, Mr. Babbage, if you put into the machine the wrong figures, will the right answers come out?" I couldn't count the number of times I've had users of systems that I've written run into an error or some bad user interface feedback, and they just keep banging away at it, generating an endless stream of errors, just expecting that by some magical process it'll start working. And I suppose they're correct in a way, because after a while I program up a fix for the bug or the user interface problem and push it to the production server, and it does just magically start working. So schools teach maths and written and spoken literacy and science. They teach multiple modes of art, but they're not taught the literacy of the modern age, which is programming. Games programming environments offer the ability to create simulations and representations of how things or people might behave, or history simulations, geography, scenes from literature, film and social interactions can be created, represented, distorted, and generally played with. It's hard to think of any other sort of play space that offers so many challenges and possibilities. So this is Game Maker, which some schools use. There needs to be more tinkering. These kids need to know that these things can be pulled apart and reprogrammed and extended and put back together in new and interesting ways. So, part 2. Lego is awesome. This is a model that a friend of mine lent me. It took my daughter and myself about 3 months to build. It's humongous. It weighs quite a lot. Lego Technic, which is kind of the core of this model, is great for building things that hold together really well. And Lego is great for playful exploration. Kids can experiment with physics and engineering, and it also happens that it's a great toy that's loads of fun to play with. Lego Mindstorms are programmable and have sensors and are cool, but they're a bit expensive and a bit clunky. But programming devices to light up LEDs or control robots, and using data collection devices like sensors and accelerometers and GPS, these things demystify technology. They allow children to work with data sets that mean something and have real-world context and credibility. Meccano is another good system for that, because I didn't want to just bang on about Lego the whole time, but their recent reboot had some problems. Bitbeams are a new open source building part inspired by Lego Technic, and Gridbeam, which is a larger scale open source flexible construction system that's been around for a few years. Bitbeams are made of laser cut wood joined together with screws and are compatible with Lego Technic. This cube actually uses Lego Technic connectors to join the corners. Everything Bitbeam is on GitHub. It's all open source. All the plans and schematics are all there for download. And all of those things you can fire off at any number of companies, easily discoverable on the web, and have the resulting laser cut parts shipped to your door. They'll even help you with the design. Open source construction toys, how cool is that? This gadget plays Angry Birds. Lego and BitBeams allow people without great physical engineering skills to experiment and create complex physical objects and have a bunch of fun doing so. A few years back, there was a bit of a revolution in hobbyist electronics. Along came Arduino, a relatively simple microcontroller-based board with some I/O headers, USB and power socket. You programmed it with a simple variant of C. Arduino was created in 2005 as a fork of an existing open source project called Wiring Platform, which itself came out of the processing project. And the idea of the processing project was to introduce people to a simple programming environment where they could do cool things. It was mostly targeted at artists. Wiring was an extension of that into electronics and kind of the real world. The Arduino IDE is still based on processing, just like the wiring IDE was. The thing is, though, Arduino was cheaper. It's still less than half the price of the wiring platform, and it was smaller. It was also open source. There was a bunch of competitors around at the same time that weren't open source. So eventually it won the hearts of enthusiasts, and now there's a huge ecosystem of tutorials and software and hardware around the Arduino core design, and it's all open source. Arduino is extensible using these plug-in boards called shields. This one gives the Arduino a wireless networking capability. It can actually form mesh networks. I've heard of a project that somebody created using one of these little boards and a smaller Arduino board, and it had a single button on it. And people would go into meetings, and they'd all have one of these things and had the button on it. And if 3 of them pressed the button at the same time, then a sign would light up in the meeting room, and it said bull dust. Well, it didn't say bull dust, it said something else. But it said, so it was a really good feedback mechanism for the people in the meeting. And it was all anonymous because these things were in their pockets. This is a weather station module. This is just an off-the-shelf weather station module plugged into a general prototyping board that's then plugged into the Arduino. Arduino weather station. And the total cost here is probably $30 or $40. That's pretty neat. There's a huge range of form factors of Arduino boards. The top one on the left there is a lily pad, and it's designed to be sewn into clothes. The only thing restricted by the Arduino creators is that you're not allowed to make a copy of the Arduino and call it Arduino. There's a hell of a lot of Arduino compatible boards out there now that generally called something Duino. And the bottom right one there is the size of a USB stick. So open source electronics, that's cool too. So what are people doing with this stuff? Just to give you an idea, I've seen projects like this one, which is a physical mailbox or physical email box. And it has a display on the front which shows the subject line of the mail and the little flag that pops up indicating that there's new mail. It has buttons on the top that you can press to do instant replies of yes or no. It's so cool. I've seen a similar one for Facebook notifications. And these projects often use Python at the top level to kind of glue things together. This one is a semi-automatic paintbrush project. You hold an ink cartridge that has an LED stuck to it. It's driven and monitored by an Arduino and a camera. Using it, you can copy great works of art or just any old picture. I've also seen automated sprinkler projects and a teletype. Who knows what a teletype is? Yeah, a teletype front end for Twitter, which is kind of neat. So Arduino allows people without great electronic skills to do pretty amazing things and have a bunch of fun doing so. The BitBeam repository even includes a schematic for mounting an Arduino board onto a BitBeam compatible board, and it just so happens that it's also Lego Technic compatible, which is kind of neat. If more people were aware of the possibilities and benefits of hacking devices, then we might not have strange laws like the DMCA, which basically intends to prevent us from pulling things apart and figuring out how they work. And this year we see the release of the Raspberry Pi, a small lightweight computer that runs Linux and costs next to nothing. It's pretty small, 85 by 50, I realise that's quite big, but the board is quite small, 85 by 54 by 17 millimetres, and weighs 45 grams. It's not the smallest Linux system out there. I know you can get a Linux system on a USB stick, but it's by far the cheapest. It has 256 meg of RAM, an 800 megahertz ARM processor, and a GPU, and it's capable of 1080p video playback. It has HDMI and composite video out, so it'll plug into pretty much any television. It has audio out over HDMI and headphone jack. Power comes in over a micro USB socket. You can power it with 4 AA batteries. It has an SD card slot, or you could plug in a USB stick for storage. And it has GPIO pins, that row of pins up the top there. That's an interface to the real world, just like the Arduino has. The current model has 2 USB ports and an Ethernet port, and it costs $35. There's a second version that'll be out soon, which loses a USB port and the Ethernet port, and it's $25. It's by far the cheapest computer on the market. Eben Upton, the creator of the Raspberry Pi, hopes to get the gadget in the hands of children all over the world. And there's a bunch of people in education who think he's onto a winner. It's interesting parallel to the Commodore 64, whose main selling point over rivals Apple and IBM at the time was the lower price. And now that the hardware is done, they're focusing on the education side. And of course, people are hooking up Arduinos to Raspberry Pis. The Raspberry Pi will even run the Arduino IDE. And you can glue it all together with Python, which is installed from the get-go on the Pi. So is Pygame. Python use is encouraged. It's practically the Pi's basic. But we've kind of seen something like this before. The one laptop per child program, also known as the $100 laptop program when it started out, which has singularly failed to take off in a big way. Why is it that iPads, which are general purpose devices that are more expensive, why are they making headway where the OLPC, which was designed for kids and cheaper, where it failed? Is it just because they're shinier? I have a feeling that that might actually be the case in some places. It's not actually clear why the OLPC has failed to take off. I personally suspect it has a lot to do with the software library. There was always this assumption that open source developers would just kind of step up and fill in the gaps. It looks like the project is still going, with the next iteration producing a tablet rather than a laptop. But I think they're probably playing a losing game of catch-up at this point. The thing is, the OLPC project and some of the projects that preceded it showed us that kids can do pretty amazing things given the right tools. We were shown that with Scratch, which is what this is, incidentally invented by the same people who gave us Lego Mindstorm. And if you've ever used Lego Mindstorm, the program interface is very similar to this. Scratch was rejected from the Apple App Store, and resubmission hasn't been attempted. Ironically, Alan Kay, the inventor of Squeak, which sits underneath Scratch, also invented the whole idea of a lightweight tablet computer. He called it a Dynabook, and he thought that children could use it to learn how to program. It could be seen as a pretty direct inspiration for modern laptops and tablet computers, including the iPad. One of the core elements of the OLPC philosophy was encouraging kids to tinker, to mess about with the programming of the devices. There's a view source key on the keyboard. I'm not sure where that's going to be on the tablet. And if they mucked it up, they could just say, oops, and revert, and the system would start working again. So it's all about code literacy, which is about how computers work, rather than computer literacy, which is about just using computers. So part 3. There's an interesting project running this year. It's called Code Year. It's been running since January. It was set up as a New Year's resolution goal for people to learn how to code during the year. Incidentally, while I was writing this keynote, which took me about 2 weeks, 4,000 people signed up to Code Year. People should know how computers work and how they may be controlled. If more people knew about how computers worked in general, then we might not have ridiculous laws like SOPA, which only exists because the authors know nothing about how the internet works. Because of course the internet is a series of tubes filled with cats. There's my kitten, Anna. Recently the case of Oracle versus Google wrapped up. And it was all about Java, how Google was alleged to have copied Java. The final argument that Oracle had put forward, that APIs may be copied and that Google had illegally copied 37 Java APIs, was rejected by the judge because the judge, during the course of the trial, had learnt a little bit of coding. He learnt enough to know that the claims were both bogus and, if he set a precedent, incredibly dangerous. Some people are concerned that encouraging more people to learn to code, about encouraging more people to learn to code. They liken it to teaching everyone to being a professional car mechanic or a plumber. The point of code literacy isn't to turn everyone into a professional programmer. It's to let them know that they can change the light bulb in their computer if they want to or need to. It's to give them an insight into a different way of thinking about problems. And anyway, if it does encourage more professional programmers, then I say more of it. We need a much stronger message that coding is okay for anyone to do, rather than just geeks or programmers. But again, we've seen something like Code Year before. The idea of getting more people introduced to the idea of coding. Computer programming for everyone started in 2000, with the goal of producing teaching materials and a nicer school-friendly interface to the IDE that comes with Python called IDLE. It floundered thanks to a lack of funding and lasted until 2007, supported by enthusiastic volunteers, but it petered out. The Python education SIG is still rolling along though, doing some good work. But coding should be about doing something, right? And preferably something fun. So I studied robotics and digital technology at university, building robots and computers kind of from the atom up to the operating system, really practical stuff. Why then am I here talking about video games? Well, a strange thing happened when I graduated and singularly failed to get a job making robots. I ended up as a system administrator. Luckily though, I discovered that programming could be fun. It just took me a little while. I discovered Python about a year out of university in '95. I loaded it from a floppy disk onto my cousin's XT PC running DOS and ran through the official free tutorial downloaded from the website. In half an hour, I knew Python, and it was awesome. At around the same time, I was just starting to figure out this new World Wide Web thing. And I developed a couple of gaming applications pretty quickly. The first one was a football tipping pool program for my co-workers, and the second one was a web-based game called Stellar Crisis. It was a pretty simple turn-based strategy game in the 4X genre, and 4X means explore, expand, exploit, and exterminate. It was pretty popular amongst my friends, but it was extremely poorly designed. Web programming was a very young field back then, and my persistence layer, which consisted entirely of pickles, was pretty fragile. I ditched that code, which kind of makes me sad now, and I started working on version 2. About every couple of years or so, I would pick up that code and shake my head, work on it a bit, and put it away again. The thing was, I needed encouragement. My first grown-up video game was written during a Ludum Dare 48-hour game programming challenge, and it was so very bad. But I learned an awful lot about game programming and general application design since then. A lot of that has come from writing a lot of games, and most of those games have been written during short-term game programming challenges. Yay, I got the teddy. Ludum Dare is the name of a web forum created by Jeff Howland as a place for independent game developers to gather. It was created around 2000, 2001. It's a Latin phrase meaning to give a game. It was here that Jeff started the regular 48-hour programming challenges. The 48-hour competition is also known as LD48 because people can't agree on how to pronounce Ludum Dare. It runs over a weekend, and the idea is to develop a game mostly from scratch by yourself. All of the programming and the art and the sound and the music are to be developed during the weekend. These days, they also run a much more relaxed game jam style challenge, which allows teams to enter and existing game assets to be used. Game assets being the art and the sound and the music. Back then, the term indie hadn't been commonly applied to video game development. There were independent developers, but they were fairly rare and generally pretty big, like Valve. The internet resources for game developers were just starting out were limited. There was a website called gamedev.net, but in general, there wasn't as strong a culture of sharing game development ideas, practices, and tools as there is now. There was certainly no movie about it. I liked the 48-hour challenges so much, I ended up running a couple in 2004 and 5 when the original organiser ran out of steam. As an aside, about 10 years ago, I participated in the newly internationalised National Novel Writing Month. It's called National because it started in the United States, of course. Anyway, the idea is you write a 50,000-word novel during the month of November. It doesn't have to be good. It doesn't even have to be read by anyone else. You just have to write roughly 1,600 words a day for a month, and at the end you have a novel. I did it out of curiosity, and partly so I could stop being one of those people who was saying, you know, one of these days I should write a novel. Also, the support network of the other participants, including my wife, helped. And in the end, I had a novel of slightly over 50,000 words with a reasonable plot, but it changed voice 3 times, and only my wife has ever read it, and she promises never to speak of it again. 3 LD48 challenges later, though, I found that family life didn't really lend itself to devoting an entire weekend to pretty much anything. Certainly not writing a video game. I also wanted to be able to collaborate with my friends and use existing art resources, something that the LD48 challenge forbade at the time. I've gotten only slightly better at drawing, and I know that the art side of making video games scares a lot of developers. I'm also a huge fan of Python, so I created PyWeek, which is now in its 7th year, and we've just had the 14th challenge. I've written 11 PyWeek games. I've not finished a few times, usually because real life has intervened. I've written games I'm proud of and games that I think are quite terrible. I've used PyWeek as an excuse to try out vague ideas and new technologies. I've actively developed and extended new tools and libraries during PyWeek alongside the games. I've won once. This game was actually on a magazine cover disc and is now part of Linux distributions, but I'll freely admit that it needs work. You know, every program you write always needs more work, right? Along the way, I've learned how to use Inkscape, which is a free structured vector drawing program that outputs SVG files. Structured means that I can get in and edit dodgy lines to straighten them out or make them bend in just the right way. Then I figured out how to abuse Inkscape's SVG output to use it as a level design tool, and how to render SVG in OpenGL. And slowly my own ability with drawing using Inkscape has improved. Another great program called Pixn helped me improve my pixel art, although I'm still pretty terrible at it. And Pixel Edit, which is a new tool that's just coming out, greatly simplifies the production of tile sets. And Tiled, for editing maps made with tile sets. These are all free tools created by enthusiastic independent developers. I've written code to procedurally generate clouds and trees when I probably could have drawn them by hand faster, but writing the code was fun. And I've generated infinite branching curves that looked kind of pretty. I've learned the values of particles. Every game is improved with particles. Every game developer eventually realizes that. My first PyWeek entry was developed with some friends, and it was a real 2.5D shoot 'em up called PowerCore. 2.5D means all the models are 3D, but the game is placed in a two-dimensional plane. It was rockin' and mostly worked as a game. It was loads of fun working with my friends on it. It had an interesting feedback mechanism. As you lost these power towers, you gained power because it meant you were losing. Of course, there's the trick that you can actually go and blow up the towers to get a power boost as well. Anyway, it was neat. My next entry was a pixel art platformer. It had only one level, and even that wasn't very good. Bouncy the Hungry Rabbit. It was my first solo 2.5D effort, which I developed all of the 3D models, the 3D space management, collision detection, and the level editor, and so on. It was also developed with a specific audience in mind, my daughter. She wanted to be able to, she'd just turned 3 and she wanted to be able to play some of the games I was making. Developing games suitable for my daughter has been a bit of a recurring theme. After Bouncy, I got together with some PyWeek regulars and had a go at a team effort. This resulted in our game Up the Chain of Evolution. It had a neat mechanic. The player would rapidly evolve, growing legs or wings or fins to suit the game demands. It almost worked. Sadly, it was let down by some glitches, and the debugging of those meant that the gameplay was a bit shallow. You might notice the trees and the clouds. I went solo for my next effort, Flatbot, in which a robot with a powerful disintegrating laser just wanted to get his soccer ball to the other end of the level to play with his friend. I contributed the tile mapping code that I developed for this game and the scrolling code to the Cocos 2D library. Yay! Then I teamed up with some folks from the XKCD comic forum to create a neat little strategy RPG called Threads of Fate. Unfortunately, I ended up doing most of the heavy lifting during that project, and it kind of turned me off working with other people for a while. Interestingly, I developed most of that game on an Asus EPC 701, which was the first of the new netbook-style laptops that were just starting to come out. 800 by 400 pixel resolution OpenGL game. It was an interesting challenge to work with. I got fired up the next PyWeek to work by myself and use my Inkscape powers to their extreme. This resulted in Abby's Grand Adventure, a platformer in which the graphics and level design were all done in Inkscape. I integrated an SVG parser into Cocos 2D's scrolling level manager, and away I went. It worked out pretty well. I think you might be able to tell how maybe the games are getting a little bit better as we go along. I don't know. Then came my strangest game. I had this idea, I've had this idea for quite a while actually, for generating infinite branching curves, but no actual game. In the end, I had pretty infinite branching curves and somewhat of a game. In PyWeek 11, I had very little time to work on the game. Ironically, I had this brilliant idea about infection, and then I came down with the flu. I did learn some new tricks in A-star pathfinding around irregular rectangles, which I blogged about, so something came out of it. I went all storytelling in the next entry. Sadly, I completely messed up the development approach. I was focusing on small details rather than the bigger picture, and so the game just wasn't finished. And my most recent game is still in development. All of my entries were actual games to some degree. I try to encourage all of the participants in PyWeek to submit whatever game they have at the end of the week. They'll get feedback and a real incentive to improve next time. Almost 1/3 of PyWeek entrants return for a second try. No one has actually participated all 14 times. One keen guy is the record holder, having come back 13 times. Personally, I've had to skip a few, and I've only been in 11. During PyWeek, I've learned a bunch of new programming skills, and I've learned about new libraries and new tools like Inkscape and Pixen. So I started out using Pygame, which was only natural because back then it was the only library in the Python game programming space. Early on, we had a couple of little programming challenges just using Pygame. There was a font challenge in 2001 where the original developer of Pygame, Pete Shinners, challenged everyone on the Pygame mailing list to create something interesting just using Pygame's font module. Who knows Underworld, the band? Yeah, Skyscraper. That was the entry, kind of messing up the top corner there. That was my entry, inspired by Skyscraper. Anyway, a while later, I ran a Pygame Draw Challenge as a kind of a mini PyWeek, in which entries could only use Pygame in the Python standard library. They were also limited to 64K code size, so they couldn't cheat outrageously. No external files were allowed. There were some truly scary entries in that challenge, including a couple of physics simulations and some hand-coded synthesizer to play music. This is a really neat little two-player strategy game. Pygame is built on top of SDL, which stands for the Simple Direct Media Layer, which is a fairly old-school library, first released in 1998, and it was developed and open-sourced by Loki Software, who were porting games from Windows to Macs, and then other platforms. I say old school because it's all about putting 2D rasterized graphics on the screen and then moving them around, accompanied by sounds and music. Pygame adds some convenience layers on top of that, but that's the basic core of it. I gave OpenGL a try in a few entries as well, still using Pygame for the underlying Windows sound and music, but with PyOpenGL on top. OpenGL was neat. It had significantly more power than Pygame for pushing pixels around, even in 2D games. But also you could do 3D games in it, which was cool. And OpenGL is an abstraction of hardware that's in pretty much every computer, including the iPad, your smartphone, and even Windows has it built in. A couple of years into PyWeek, just as C-types adoption started kicking in with its inclusion in Python 2.5, and coming off the back of re-implementing Pygame in C-types, a project unfortunately was then rejected by the Pygame maintainers, Alex Holkner decided to see how much modern operating system facilities could be used to improve on what we were given with SDL. The result was Piglet, and it had a much nicer API, but also allowed for more powerful games to be developed using a simpler API than just straight OpenGL. The unfortunate thing about Piglet and OpenGL games is that they rely on a reasonable OpenGL implementation. And unfortunately, that's not something that's always a given. Piglet provides many of the same facilities that Pygame does, but without that external SDL requirement. It's a pure Python library. It also wraps OpenGL in a couple of layers of abstraction, allowing a much nicer interface to the high performance but kind of messy to manage vertex buffer objects and vertex arrays. It manages the objects, handling allocation and deallocation and shuffling things around as need be. On top of that are layers handling rendering of text, and there's even an abstraction for sprites. There's another layer on top of OpenGL texture management as well. So there's a similarity in terms of the core functionality provided by Pygame and Piglet. Though Piglet then uses OpenGL, or the power of OpenGL, to provide additional possibilities through having many more sprites on screen and being able to do operations on sprites like rotation, scaling, and fading. And also, again, it has no external core dependencies. So it actually runs under PyPy. Piglet is now in community hands and is under kind of active but slow development. There's been some big hurdles in getting it working on 64-bit platforms, in particular OS X. Originally, Piglet was developed running over the older Carbon framework, and one developer has the unenviable task of now migrating us to the newer Cocoa and Objective-C framework. He's ended up writing a C-types interface to Objective-C to accomplish it. I'm hopeful that a new release will be made in the near future, hopefully before the next PyWeek in September. One PyWeek team noticed that they were redeveloping a lot of code each time they wrote their games. So they created a framework based on some of their code and called it Cocos2D. It's a layer on top of Piglet and contains a bunch of the same stuff that you always end up rewriting every time you develop a game, even though it's not actually game logic. It's things like managing scenes, loading and displaying tile maps, animating sprites. Cocos2D has lots of tools for making your games more juicy. It's easy to make a sprite rotate, scale, fade, or explode in a shower of particles. You can even make entire scenes wobble or mutate. I've written a few games in Cocos 2D and contributed some code to it. The original core developers have moved on to iOS and Objective-C, but there is still an active core developer still adding new features to the original Python implementation. And I'm still pitching in every now and then. I just added TMX format tile map loading. That's the format that's generated by the tiled map editor. And these days, PyOpenGL has been re-implemented in C types as well, with a scene graph accelerator written in C. There's also this Kiwi project, which is promising, but it's still a touch alpha. It has the promise of being able to write a game that is easily portable to multiple devices, including Android handsets. I'm developing something in it that I think will be pretty cool. There's all manner of other libraries. There's Panda 3D, the Blender game engine, and a ton of others. But it's probably best just to stick with the safer ones. Pygame runs everywhere. Piglet works almost everywhere, especially after people upgrade their video card drivers. So, getting started. If you're new to programming, then I really recommend invent your own games with Python. It's written in the same style as the books that I grew up with. It has a progression through basic programming ideas of arithmetic, variable assignment, flow control, through to text-based games, and finishes up with games with sound and graphics. And all the way along, it has code samples to copy at each stage, and lots of great annotations to help understanding. Also, you have the choice of buying a printed book or downloading a free PDF. If you're already confident with programming, then there's some other books you might try. Beginning Game Development with Python and Pygame, Game Programming the L line, which I think is actually for a less sophisticated audience, and then Making Games with Python and Pygame, which is actually a follow-on from Invent Your Own Games by the same author. And again, a free download, or you can buy the book printed. Alternatively, try some of the online tutorials that exist for Pygame, Piglet, and Cocos 2D. Just Google them. There's also the tutorial I presented at this conference. The materials are all online at Bitbucket, and there's a video of the presentation there. And then do PyWeek, or LD48. You'll most likely produce something game-like the first time you try. Or maybe you don't, it doesn't matter. Just learn from the experience. I maintain a sticky post on the PyWeek discussion board where I collate links that I think might be useful to PyWeek participants. It's all about advice and tools and resources. There's a similar page on the Pygame website. And don't get hung up on graphics. There's tons of free graphics to use out there already. And if there isn't, just have a good go at it. Or use blocks, lines, and circles. Tetris is one of the most popular video games of all time. Then have a look around for some techniques. Read some of the post-mortems written by other PyWeek entrants. Look at some alternative libraries. Read the source of the winning games. PyWeek requires that entries are open source. You have to submit the source with your game. And a bunch of them use things like Bitbucket now. And then do PyWeek again. This is important. Don't do PyWeek just once. So, final part. Some Zen, or just some thoughts inspired by Tim Peters. Don't agonize over figuring out the perfect solution to a problem. Just work out something that gets the job done. Don't overgeneralize with the intention of using the additional flexibility later on. Refactor later when you need that flexibility. It's almost always a good idea to pare back a game, or really any application, to some simply implementable core. You write that, and then you add on the additional gameplay or functionality later. And if you find that you're staring at some code, or maybe even a design, and are having trouble figuring it out, then maybe it's time to toss it all out and break the problem down into smaller, more understandable parts. These are all things that I've learned over many years of writing games during a week. Video games can be a great way to introduce coding or develop coding skills. Through writing multiple games during short challenges, you can learn useful programming techniques. And they're a great outlet for creativity. And they're fun. That's all I have to say. So I don't know whether we've got time, but if you have questions, I'd be happy to take them. Excellent.
What's your motivation when making games? Is it for the community to learn more games like that, or you want to have more people?
My motivation for writing games is just to have a bit of fun. For me, as well as for the people who might play the game. It's both, actually. Actually, sitting down for a week and banging most of us who have a regular programming job, we sit down and we're working on the same thing day in, day out, same project for months at a time, and it gets a bit boring. Being able to just say, look, for a week, I'm going to focus on something entirely new and different. It really reinvigorates your whole approach to programming. It's just fun. Okay, so the question is whether or not it's better to perhaps instead learn Objective-C so that you can then publish your game on the App Store and maybe make a few dollars or have a slightly wider audience. Well, there's a question about whether or not you'll actually get a wider audience if you publish something to the App Store because the vast majority of things that are published to the App Store don't get an audience. But it comes back to your own motivation. If you're interested in making money, then yeah, the App Store is the way to go. And that's just not my motivation. I get enough people playing my games just by participating in PyWeek.
Okay, have you heard of talk by Cory Doctorow CCC sometime back, the war against general purpose machine?
Cory Doctorow in which?
In CCC conference, Chaos Computer conference.
Oh yeah.
So it already happened. Some of the we can't open up computers anymore.
Yes, Cory Doctorow is quite well known in the circle of makers and people who are thinking about these issues about computers that cannot be opened. Yes, and he certainly has a blog where he talks about these things quite a lot. Yeah.
So when you said about previously when people had Commodore 64 coming out with the manuals and many of us learned the programming basic style and stuff like that. These days, I think that the world has changed a bit. Like the equivalent, if I can see, will be to get someone the Corona's ID, the game development ID, and let a child or someone who's learning to develop a game, which will involve the same mechanics of same creativity, but it involves some money and the walled garden and everything. That's true, but the child will be motivated in a similar manner to develop a beautiful game, publish it in an iPhone or an Android, or and see his friends play. So should we restrict that or no? I mean, we should allow that, right?
Yeah, so there are definitely environments that are available, like GameMaker. You can go out and you can buy GameMaker and you can install it on a PC and away you go. And you can do other things to set up an environment that you can do these things in. My dream would be that I could plug the PlayStation into the TV and it would just boot up into something that I could use to program, just like the Commodore 64 did. And there's really no reason why they couldn't have that available. It's just that they didn't.
Well, it's also worth a lot of money.
Well, yeah, there's some other stuff that comes with the Sony PlayStation that's obviously cost them a lot of money that's of dubious use, like home.